This video covers the last section in Chapter 7 on the parabola. We talked about parabolas back in Chapter 3, however, here we're going to look at them from a different perspective. A parabola is the set of all points in a plane that are equidistant from a fixed line, called the directrix, and a fixed point, called the focus, that is not on the line. So when we studied parabolas before, we were studying functions. So we only studied vertical parabolas. So they either opened upward like this, or they could have possibly opened downward. All right, so we locate the vertex, HK. But this time we're going to use this equidistant idea here in this definition to sketch the rest of the graph and locate these other two pieces, the focus and the directrix. So in a vertical parabola, one that is going to open upward or downward, that would be the type we talked about before, we can find our vertex HK. And then from our standard form, we can identify this number P that will tell us how far to move from the vertex to reach our focus and our directrix. So let's look at these equations as we talk about these pictures. So the standard form for a vertical parabola in this section is going to look like this. This is a little bit different looking, actually a lot different looking than the way it looked in Chapter 3. X minus h squared equals some coefficient sitting in front of this side is equal to 4p times the quantity y minus k. All right, so this would represent a vertical parabola because notice the y is not squared, but the x is squared, right? So it would be similar to y equals x squared, which is the one that opens up and down. So our vertex is the hk. Again, h is always with x, k is always with y. So the value of this coefficient is going to tell me if it opens up or down. So if p is greater than 0, a positive number, is going to open up. And if p were negative, being a number less than 0, it would open down. So if I have a number sitting in front of this right side, I can equal that to the expression for p and then be able to solve for the value of p. So if the p value is positive, we would move up a distance of p and put a little point here. That point is called the focus, that ordered pair. We would have to know at least one point on either the left or the right of my vertex and my focus. So it's always going to be that if I move up a distance of p, then I can move either right or left or both a distance of 2p, and then that would give me 2 points on either side. If this opened downward, we would have started the vertex and gone down p and then left and right 2p, and we would have gotten an upside down parabola. All right, the opposite direction of the focus, the same distance, p, is where we find the directrix. And the directrix is in a vertical parabola, the directrix is a horizontal line. So its equation is y equals a number. And we're just going to read that off the graph. It's technically, if I'm going down from the vertex and the y value here is k, it's whatever k is minus p. That's the number, but it's just easier if you're looking at a graph just to see where it is and write it down from the location. All right. In this section, we will also see parabolas that are horizontal, meaning that they're not functions. They have a very similar standard form, and we utilize the p-value and the focus and the directrix exactly the same way. So the standard form for a horizontal parabola, notice what this one was. All that happens here is you're going to take this y minus k and the x minus h, and they're going to switch places. So we're going to have y minus k being squared on the left equal to 4p times x minus h on the right. So when the x is not squared, but the y is squared, it is horizontal. When the y is not squared, but the x is squared, it is vertical. In a parabola, only one variable is squared. So our vertex is still hk, just like always. H is with x, k is with y. Doesn't matter where they're at. In this situation, if p is positive, because it's horizontal, a positive value of p is going to mean opening to the right. And if p is less than 0 or negative, it's going to open left. So we're moving horizontally right or left based on the value of p. So this is an example of it opening to the right. So if we locate our vertex HK, we move to the right P, we plot that point, that's our focus. We would have to go up 2P and down 2P to get to 2 points on either side to sketch our parabola. And then from the vertex backwards, the other direction, the same distance P, gets the vertical line called the directrix. And a vertical line will have equation x equals a number. So we're just going to go through several examples of sketching horizontal and vertical parabolas. So this first example, we're given y squared equals negative 12x. This is standard form in which h is 0 and k is 0. We can tell this is horizontal because it's x is the number on the right side, or the variable on the right, that is not squared, and y is squared. So that fits this form. So it is going to move horizontally. So the coefficient of this right side is equal to the 4p. That's this right here. So in our case, that number is negative 12. So we're going to set 4p equal to negative 12, divide both sides by 4, and get p to equal negative 3. So if it is horizontal and p is negative, less than 0, that means it's going to open left. So I move left to get to the focus. So from my vertex at 0, 0, left 3, right here, I'm just going to label that with an F. That's the focus. I'm just going to write down the ordered pair from the graph, negative 3, 0. My directrix, if I need to state it, just goes the other direction, 3, to the right. So this is a vertical line at x equals 3. You will have to plot your parabola on these. These are not all multiple choice. You're going to have to graph these parabolas. So you'll pick your horizontal parabola, plot your vertex, you'll move over a distance of p, whichever direction it moves, and then whatever p is, you're going to double it. So if p is 3, that's how we double that and we get 6. So I'm going to go 6 up, plot a point, or 6 down and plot a point. So either one of those points would be enough to then have it sketch the graph. So focus negative 3, 0, directrix x equals 3. And I just read those off the graph rather than trying to memorize a bunch of formulas for those, because you already have a lot here that you have to know that is new in this chapter. If you just have a feel for how to sketch the graph, you can just state those results once you've identified them from your sketch. All right, the next example, we have x plus 1 squared equals 8 times y minus 3. So this time y is on the right side that's not squared, and x is squared. So that means it's going to be a vertical parabola. The 4p value is the 8 this time. So 4p would equal 8, meaning p would equal 2. So if it's vertical and p is positive, it's going to open up. So we're going to move up to get to the focus. Our vertex, h is negative 1, k is 3, so negative 1, 3. We'd start that right here, negative 1, 1, 2, 3, right here. We said p was 2, so go up 2 to get to the focus. So that lands me on the graph at negative 1, 5. And then we double the value of p. So if p is 2, we double that and get 4. So I can go 4 left and plot a point, or 4 right and plot a point. And then it would sketch my graph for me. The equation of the directrix is the same distance from the vertex, but the opposite direction of the focus. So if we went up 2 to get to the focus, we go back to the vertex and we go down 2 to get to the directrix. So if I was up here at y equals 3 and I go down 2, now I'm at y equals 1. So my equation of my directrix is y equals 1. I don't know if you have to sketch the directrix on the graph. I think it might just be the parabola, but they will ask for the ordered pair of the focus and the equation of the directrix. All right, so once again, if we don't have it given in standard form, we have to know how to get it to standard form. So y squared minus 2y minus 12x minus 35 equals 0. So we can tell this is a parabola without doing any work because only one variable has a second power. We have a y squared term, but we do not have an x that is squared. So that's how we know it's a parabola. One variable is squared. We will need to complete the square, however, to put it in standard form. So whichever variable is squared and any other terms that contain that variable, we're going to keep those on the left. So we're going to keep y squared minus the 2y on the left plus blank, this was blank before we started, equals, and then the other two terms, the minus 12x and the minus 35, would move over here. So add the 12x and add the 35, and we'll have a blank to balance that next step out. So we complete the square, take half of negative 2, which is negative 1, squared is 1, we add that here. So to balance it out, we add it here. I don't believe there's going to be any coefficients to factor out on these like there were before. So whatever is added here, the same number is added here. So this left side then factors as y minus 1 squared. That's the whole purpose of completing the square, to get it to that form. This side we're just going to clean up first. So 12x plus 36. Then once this is cleaned up, you're going to factor the coefficient of x out. So 12 gets factored out and leaves x plus 3. Now we have standard form. So it is horizontal because the x is the variable over here on the right side that's not squared. So it's going to be a horizontal hyperbola. 12 is the value of the 4p. So if 4p is 12, p is 3. So a positive value of p in a horizontal parabola, I think I said hyperbola a minute ago, that should be a parabola, it's going to open to the right. So negative 3, 1 would be my vertex because this is x plus 3, so h is negative 3, y minus 1 means k is 1. So I would go left 3, up 1, and plot my vertex. My value of p was 3, and it's positive, so I go to the right 3, 1, 2, 3, and land at my focus. So here I would be at 0, 1. Just read it off the graph. We double the value of p to get another point for my parabola. So again, if p was 3, double that, you get a 6. So you can go up 6 and plot a point, or you can go down 6 and plot a point to get the sketch. And then your directrix would move the opposite direction of the focus from your vertex. So if I move to the right to get to the focus because it opened right, I have to move left to get to my directrix. So if I was already over here at negative 3 and I move left 3 more, this directrix is a vertical line back here at x equals negative 6. So that's my equation of my directrix. So there's not a lot of problems assigned in section 7, 1, 2, and 3. You should expect to see probably in each section one that has a center or vertex at the origin, at least one, maybe a couple. Probably one that's in standard form where it's not centered at the origin, and then at least one where it's not in standard form and you have to put it there. Okay, so at least those 3 different kinds, and you may see a couple others other than that that are similar but nothing different. So that wraps up the end of chapter 7.